The Chem 342 experiment that we are now going to explore is the synthesis of methylbenzoate via the Fischer esterification process. Now, the Fischer esterification process is a long, drawn-out reaction, so you're not going to see the entire reaction in the time of this video, but you'll get the full benefit of it when you run it in your own experiment time. So the first thing that we're going to do is to select the vessel. It says in the experimental directions to take your 100 milliliter round bottom flask. You have a cork ring as well. And I'm going to put in a little football stir. Now notice I didn't drop it from a distance. Okay, I let it slide into the vessel. The reason is that you don't want to break the vessel. Okay, now the experimental details say you're going to take 10 grams of benzoic acid, which I've previously weighed out, and I'm going to, using a funnel, I'm going to put that into the round bottom flask. Okay? And we'll put these back over here. Okay. Then the experiment says you're to take 25 milliliters of methanol. And let's do that as well. Now, this does not have to be exact. If you take 27, if you take 24, that's fine. But you have to know how many milliliters of methanol you actually use in the reaction. And that will go back there. All right. I'm going to pour most of it into the round bottom flask. I'm going to hold back a little bit of it, just maybe about a milliliter, so that we can wash out the graduated cylinder in which I'm going to put sulfuric acid. So here I have a little 10 mil graduated cylinder, and I'm going to get some sulfuric acid. Now at this point, please be careful in measuring out the sulfuric acid. It will be just as bad as everybody's been telling you for the past 20 years. Okay? I'm going to measure out 3 milliliters of it. Now, we're using sulfuric acid as a catalyst, so you don't have to measure this out precisely. It's a catalyst. The reaction will go a little bit faster if you use more, a little bit slower if you use less, but 3 milliliters seems like the amount that is optimal for this procedure. Now I'm going to clamp the round bottom flask to our flexible frame here, and I'm going to clamp this. I like to use a 3-prong clamp for this sort of a thing. And get that in there. And then I'm going to use a heating mantle. Now this heating mantle will be placed under here, and this is going to heat my 100 milliliter round bottom flask. And we can probably even turn this on. I'm going to turn on the, turn on the stir. Now, not all of the benzoic acid is going to dissolve at this point, but it will dissolve when we heat it up. So we're going to take my sulfuric acid, and while this is stirring, I'm going to introduce the sulfuric acid into the reaction mix. Now, we're going to put it in dropwise. We don't want to put it in all at once because this would create an exothermic reaction which would boil the methanol, and it might just boil a little bit too vigorously and come out of the round bottom flask. Put that in there. And just a little bit more, like that. Now, the reason that I held back about a milliliter of methanol is to rinse out this graduated cylinder. That goes over there. To rinse it out so that we get reasonably complete transfer of the sulfuric acid into the reaction mixture. As I said, it's a catalyst, so this doesn't have to be 100%, but it should be reasonably complete. Okay, now we're through with that. All right, so now that's heating up. And while that's heating up, I can construct the rest of the apparatus. I'm going to be using a narrow water condenser. And remember how these are set up with the hoses that are available to you in the apparatus drawers under your hoods. We use these tubes that have splayed ends on them so that they go over easily the inlet and the outlet for the condenser. These then are going to fit in to the round bottom like this, and we're going to put water in the bottom one, and that's going to go like that, and water is going to come out the top. Now the rate of water flowing through the condenser does not have to be very, very fast. In fact, that's actually pretty good the way I have it there now. Let's get this on the other side. And there. We don't have to treat the reaction in a special way. We don't have to put any type of apparatus to keep out moisture or air, anything like that. This reaction is not very sensitive to moisture and air. In fact, there's water generated in the reaction itself. Let's let that go. Now, the Fischer esterification procedure calls for a long reflux period. And we're just going to turn up the variac now to whatever temperature gets the methanol boiling. And we're simply going to leave it there. Now, got to hook up our heating mantle in here. And eventually this temperature will get up to the point where this will reflux. Now, what is reflux? Why do we use reflux? Well, there are two reasons. Because the condenser is here, and it's much colder up here than it will be down here, the contents, which may volatilize up into the condenser, will condense back down into the reaction. So you're always going to keep a constant amount of material in the reaction vessel. Plus the fact that although the temperature of the reaction medium is going to change a little bit because you're producing methylbenzoate and you're depleting methanol, the boiling point is going to go up a little bit, but we will be able to run effectively a constant temperature, or a constant temperature, and we won't have to monitor the temperature in here because it's never going to get very high, because methanol in this case is in large excess. So we'll just let that go, and eventually this is going to